Hi everyone. I'm going to be doing number 25F of the Siegel book. And I think it kind of it's a little bit different from the ones I've been doing. And hopefully it'll be clear up some things I've said earlier. So let's just take a look at it real quick. Okay. So the question says, what is the pH of a 0.2 molar solution of, and then we're going to come down to F, NH4Br. So I'm first just going to do the problem. And I'll kind of explain the differences between this problem and number 24, which if we look at number 24 has the same concentration, and actually it's a very close pKa, but your actual overall pH at the very end is very different. So just looking at 24 again, which I also have a video up of, is this. Calculate the pH of a 9.2 molar solution, or 0.2 molar solution of a amine that has a pKa of 9.5. Okay, so keep that in mind. You can come back to that actual problem when I'm talking about it later. But first of all, let's just solve this one. So if you look at your Gary and Grisham book table on page 39 in the 4th edition, which is the one I have, you're going to find that the pKa of this is 9.25. Our concentration is 0.2 molar. So let's draw out our equation here. Okay, I'm going to add in water as well. Okay, now we see this right here. I'm going to cross out the Br. Cross out the ions. That's going to be a plus. Okay. The pKa of this is 9.25. So what's the pH? This is going to be at the start 0.2, 0, 0. The finish 0.2 minus x, x, x. That's separate products of reactants. We're going to cross out our x because x is very small compared to 0.2 in our overall, in our very ending answer. This doesn't happen all the time in practice or applications. Sometimes x is greater than 0.5% of 0.2 or whatever our starting thing is, but from what I hear, Professor Gassier says that he won't give you a problem where you can't cancel out x. But our pKa, so this is going to equal our Ka. And that Ka will be 5 times 5.62. So we raise base 10 to the negative 2.5, and we get 5.62 times 10 to the negative 10th. Okay, multiply this by 0.2. 1.02, I believe. $1.12. I'm sorry. Okay. Take the square root of this. It's going to be 1.06 times 10 to the negative 5th. This is going to be our final answer. Or not our final answer, but that's going to be our final concentration of the H plus that we have donated to H2O. We're going to take the log of this, the negative log, and we're going to get 4.97 equals our pH. Siegel has 4.98, but 0.01 off is fine, just due to rounding. I didn't round any of my figures, Siegel probably did. So that's due to the difference, but close enough. Okay, so why do we take the pKa of this one? And number 24, where the pKa of that one is 9.5. It's still really high. So why do we do those two? And the other one where we had the pKa of 9.5, the answer turned out to be 11.4. So what's the major difference of this? So the major difference is we have to look at our formulas. Our amine, I'm just going to write A for the base. Let's just write HA. So what this is you can solve it using the pKa or the pKb of each one. However, the reason we know which one to use is because going this way, we're using the pKb. This one's 9.5, 9.25. This one would be 4.5, 4.75. Okay. So what this means is that in order to set up the problem in the simplest way, you want to see which one is making water, or which one is a major contribution to water. This one is going this way, it's making water. This one is going this way, that's why we're using this 9.25 and 4.5 over here. So this would be a class 2, I believe, where we add base, which is a pure base. This is a class 1, which is a pure acid. I asked this question because I wasn't exactly sure of how to explain it. And I think I have, when I made the problem number 24 video, I did kind of explain it a little bit wrong. So if you are unclear about anything, please check the chat room, because Professor Gassier has responded to that and has probably provided a better explanation than I can. So that is the answer, and that's how you get it. And I hope this helped out. If you have any questions, please send a comment, or I'll see you on the chat site.